Hello, my name is Manuel, and I'm joined by Allison, Duran, Angie, Garza, and Capri, Crespo. We're the C2023 Time Travelers Group 3 of the Earth Systems Explorers, and we're going to be doing a case study over Hurricane Harvey from 2017. We're going to see how cloud coverage can help us see the causes and effects of these hurricanes. So, first heading into our project, we first wanted to provide a research paper that we could eventually get published, but also a deep insight into a very interesting topic and get this idea going to the AGU Science Conference. So, about Hurricane Harvey, first, it was a really destructive hurricane in recent U.S. history that landed on the Texas coast in the August of 2017. And cloud coverage is a very important factor into this since it can provide a lot of valuable information to the development and formation of these storms. So, about our process, we first analyzed hurricanes as a whole, and then we went on to El Nino and La Nina and climate change, since they all played a very important role into this hurricane. And then we saw hurricanes had patterns with clouds and in regards to the characteristics and effects.
Hello, my name is Allison Duran, and I'm part of the Time Travelers Hurricane team. The effects of climate change on Hurricane Harvey. Climatologists agree that global warming contributed to Harvey's impact. Studies have found that the amount of rainfall was 38% higher because of global warming. There are three main reasons for this. First being the Gulf region air temperatures were 2 to 3 degrees hotter in Fahrenheit in the past years, which allowed for the air to hold more moisture. Second being the rising sea levels made flooding more likely near Gulf Coast cities. The sea levels around Houston were 6 inches higher than 20 years ago, particularly due to warmer temperatures, melting ice caps in Antarctica. Third, global warming stalled weather patterns in the region that allowed Harvey to hover over Houston instead of moving back out into the ocean. The convergence of all three effects allowed Harvey to drop feet of rain instead of inches.
Hello, my name is Angie, Garza, and today we'll be talking about El Nino and La Nina. As you can see in the bottom right hand corner, I added that picture showing that how they're both different. El Nino brings colder and wetter environments, while La Nina brings drier and warmer temperatures. Now, La Nina affected Hurricane Harvey because during Hurricane Harvey, it entered the Gulf of Mexico and we were experiencing La Nina, and it actually grew bigger and stronger because of those warm waters. Not only does La Nina bring warmer waters, but it also brings pretty distinctive rain clouds. So during La Nina, more hurricanes and storms form because of those warm waters. So most clouds go off in the ocean and create those storms, leaving us looking up in the sky from the ground, not seeing as much cloud coverage because they're off in the ocean. So we can use satellite imagery comparing cloud coverage between La Nina and before a hurricane or a storm. And if we can see that the cloud coverage is somewhat similar, it shows that it will be a bigger storm and hurricane than we would be expecting. And comparing to El Nino has bigger, white, fluffier clouds. So if we see that before a storm, it shows us that it won't be as big of a storm that we should be expecting. Now that's how we can use La Nina's cloud coverage to compare how big of a storm we should be expecting. Thank you.
Based on what we just learned, we can see that La Nina actually causes colder clouds because the warm air that it brings to the south rises quicker. This rising air causes the clouds to become extremely condensed and become also extremely cold due to the higher elevations they experience. Also, hurricane clouds tend to be colder, so those does correlate pretty well. After the hurricane passes, the sun shines and the clouds eventually dissipate due to a sudden increase in temperature. Also, low wind shear causes more damage since it allows the clouds to stay together more and keep their structure and strength while the hurricane passes. As you can see here in this graph, Hurricane Harvey actually experienced the greatest maximum wind speed right here before it entered, and then it caused the most damage here, which is actually where it had the lowest wind speed. El Nino also brings in thicker, more condensed clouds due to pre-existing cold temperatures. We can see here that El Nino, 1 year before and 2 years after, we can see that those are pretty thick, condensed clouds already. And also here in this graph from our Globe Observer app, that's also pretty condensed clouds right there. Texas is actually expected to get a hurricane this year or next year. As we can see, the clouds look similar to the ones we see from the satellite image right before Hurricane Harvey and also after. Thicker clouds from El Nino mixed with the warmer, newer air from La Nina is a perfect recipe for disaster.
In conclusion, overall cloud coverage observations obtained through satellite imagery and ground-based instruments offer valuable insights into the dynamics and behavior of hurricanes. Integrating cloud data with other meteorological variables enables forecasters to improve hurricane track predictions, intensity forecasts, and warnings, ultimately helping to mitigate potential impacts on affected areas. We would like to acknowledge and thank the Seas Earth System Explorer mentors, Dr. Russanne, Ms. Cassie Soeffing, Mr. Peder Nelson, Dr. Erika Podest, Andrew Clark, and Yashraj Patil, and all of the necessary speakers.